Good morning, everybody. Welcome to Code4Lib Day 2. I'm just going to keep going, so it's on your own recognizance to, calm down. Welcome again to Princeton and the second day of Code4Lib with slightly fewer talks and a little more interaction. One of the things we would ask, we're happy for you to interact with one another and with the speakers. If you want to be sharing questions, if there's no QA time, feel free to drop them in the Code4Lib Con Slack channel. And if you start with a capital Q at the start, that'll help us more quickly identify questions for the speaker. Also, we have breakouts today. There's still some available timing if you want to propose a breakout. The sign up for that is where the sign-ups for lightning talks were yesterday, over by the door with the slightly X'd off caution tape. There is also the sign-up for lightning talks for tomorrow. There's space available. All the ones for today are full, but we still have a little time for tomorrow. Also, the local planning committee has provided a lovely opportunity for tours tomorrow afternoon after we wrap up with the main conference. And there's a campus tour at 2 p.m., tours of Lewis and Firestone libraries at 3 and 4, and the digital imaging studio at Firestone at 3 p.m. and 4 p.m. Sign-ups are available via the social activities page on the conference website, so head over there for that. And now, also, since we will be having some poster sessions this afternoon for poster presenters, the display boards are going to get set up during the lunch break. Each poster presenter will get one side of the board or a poster easel. We have push pins or tape available. So we ask that you set those up before the poster session at 3:15. So if you're dealing with a poster, they'll be available to start setting up around lunch or a little after, and be ready to go by the time poster sessions get rolling. And as I play with the scroll bar here a little bit, we'll help move this thing along. And also, we have our lovely community support volunteers. And this morning we have, as community support volunteers, what are even days? So, all right. So we have Thomas Dowling and Bobby Fox here on site from 8:30 to 11. And then we have Andromeda Yelton and Su Jong from 11 to 1. And they will be in the back of the room. Feel free to raise your hand or wave just to let people know who you are. Also online in the Slack, we have Andrew Bettolini by that name on the Slack channel until 11, and Eric Fetaplace, Fet23 on Slack from 11 to 1. And also we'd want to then congratulate this year's Diversity Scholarship residents. So I'm going to list off a few names and hopefully not butcher them. If I do, my apologies. You can correct us later. So this year's Diversity Scholarship recipients are Tara Dorj, Will Nyarko, Natalie Kozier, Akshay Argawal, Rochelle Cook, Olawuse Noah Abebanjo, So those are our diversity recipients. So let's give a round of applause to them. As well as a big thanks to 4Science, Princeton University Libraries, Penn State University Libraries, and the generous individuals of the Code4Lib community that have made these scholarships possible. And we'll also want to give quick thanks to our supporter level sponsors, which are Carnegie Mellon University Libraries, Archive Space, and Project Reshare with the Boston Library Consortium. And with that, I don't think we have any other notable odds and ends. So hopefully our speakers are ready to roll. And we can get started with our first speaker, Brian Kane, who will be talking about replacing digital repository infrastructure at Los Alamos National Laboratory, and he'll be speaking for 15 minutes.
Okay, cool, thank you. How's the volume? Is it okay? Perfect. All right, so let me get this going. Apologies. All right, thank you. My name is Brian Kane. I am a librarian at Los Alamos National Lab. This is also my first Code4Lib as well. So yes, I will be talking about our project to replace our repository infrastructure. So just real quick, a little bit about Los Alamos. We are a Department of Energy national laboratory, part of the 17 national labs within the Department of Energy, and we work across various DOE mission spaces, including national security, science, and energy. I work in the research library in Los Alamos, and of course, because it's Los Alamos, a bunch of stuff is named after Oppenheimer, so I work in the Oppenheimer Study Center. And because we do have a focus on national security, LANL operates in a strict security constraint environment. This means limited options for cloud services, scrutinized software origin, and complex access requirements for information. Our systems also span siloed networks, which is a challenge for us in terms of synchronization and data integrity across these isolated environments. So with all that as context, the library had been running a legacy repository called Adore. It was designed and developed by the research library between 2003 and 2005. So although it was pretty nifty and robust, it was time to replace it. It was running on very old hardware and with software facing imminent deprecation. We were experiencing increasing instability, and with no clear way to really update it, we faced escalating maintenance challenges. The system was also pretty cumbersome to interact with. It required numerous manual steps for record ingestion and editing tasks, and really lacked modern API features. Additionally, we were the only institution using Adore, which obviously limits community support and any broader knowledge acquisition about the system. And there had been several past repository replacement efforts at the laboratory. Prior attempts to replace Adore using DSpace Chris in 2018, Invenio in 2016, and Hydra Fedora in 2014. These all failed due to issues like misaligned platform choices, limited dedicated team capacity, underestimated project scope, and emergent technical disagreements. These challenges highlighted the need for a better approach to figure out a way to overcome these past barriers. So we had initiated a repository investigation and evaluation project. Our goals were to identify possible technical issues with platforms, before implementation, build consensus and knowledge within the team on the repository platform choice, and properly scope and organize an implementation project. We did this evaluation from February to April of 2023. We developed a scoring matrix for system capabilities and chose 5 candidate platforms: DSpace, DSpace Chris, Invenio RDM, Samvera Fedora, and Dataverse. And we would try some proof of concept customizations. Ideally, we'd arrive at a choice for a repository platform, document implementation requirements, all while building our skills and knowledge about these various systems. We organized the evaluation project using Agile methodology. So we had 1 project manager, a scrum master, a tech lead, 4 software developers, and 4 librarians and library techs. We organized our work into stories and tasks that we put into bi-weekly sprints, and we used tools like Jira to organize those sprints. So for our evaluation matrix, we came up with 60 consensus capabilities we wanted to score for these repositories. We had 10 broader categories we organized these 60 into. So things like metadata in a system. So if we had experience as like a metadata person, you'd score on those metadata-related criteria. If you were a developer, you'd score on things like system or security capabilities. So regarding the systems we chose to install, we only considered open source solutions because we had to install everything on local networks, so no cloud systems. We also had a compressed timeline for this project, and knowing the amount of needed customizations for the system, it was unlikely any vended solution would really work. And unfortunately, Invenio RDM and Samvera Fedora shipped with features and configurations that were not ideal for LANL's network and security policies. So after like many failed attempts to try to get those installed, it seemed unlikely that there were going to be viable production options, so we did no evaluation for those. So on the right, you can see our final scores, which was just a starting point for our discussions. We had a general consensus that really Dataverse or DSpace-based systems were viable. Each system had various pros and cons that the team discussed and recorded during evaluation work. So we continued to investigate these items before reconvening for a final decision. So after discussion and secret voting, we unanimously decided to go with Dataverse as our core repository, which was surprising because it's not traditionally thought of as a generalist repository. But given all of the learning, testing, and understanding garnered during our evaluation process, we were confident that we could make it actually work. This evaluation was extremely helpful for the implementation project. We answered a lot of questions, developed skills, built the foundation for our implementation just overall. And more than anything else, it clarified the overall design and needed features of our future repository ecosystem. So we reconvened the repository team in September of 2023 to begin the implementation project, which then ran through to June 2024. This project encompassed the replacement of Adore and its functions, migration of legacy records, rebuilding workflows to move objects in and out of the repository, and system integrations across internal and external networks. So just taking a look at our overall architecture, while Dataverse is a key component of our repository ecosystem, we recognize that Dataverse couldn't replace or replicate functions of several of our essential systems. So for example, most repository content comes through user deposit via review and release system. So if someone wants to go publish an article, they have to put it into this system, and then once approved, it will feed automatically into the repository. We also determined that our internal search UI must run separately from Dataverse. Additionally, we need to integrate with several external systems, like the Department of Energy's Office of Science and Technical Information System, OSCE.gov, to manage all of these at OSCE.gov. So to manage all of these interactions, we concluded that an orchestration layer was essential for success of the repository replacement project. Our orchestration system is a custom, flexible, and robust middleware application to manage all aspects of interaction and integration of the Dataverse repository. It was created using the PHP software development framework, Laravel. It has API functions to interact with Dataverse, as well as other component parts of our ecosystem, including Solar cores and other homegrown apps. It manages and tracks all actions of ingestion, update, deletion, and deletion of digital objects, and heavily uses queue jobs, approximately 40, to automate workflows. Each job performs a single task with fail-safe mechanisms for reversal and built-in validation to ensure well-formed metadata and system actions. So if we send something out to Austy and we don't get a successful deposit message, we will get an error message telling us that we need to go investigate something. With that part built, we can now migrate legacy repository assets, approximately 450,000 records dating back to the Manhattan Project. Records were stored in Adore in MARC format, but most with non-standard fields and data. So in the end, we had to create a very expansive metadata application profile based on both the contemporary records that we're currently creating and the legacy records dating back to 1943 or so. We also preserved all versions of these records and assets, which meant approximately 700,000 deposits with over 1 million files accompanying them. At the same time, we had to integrate Dataverse with other production systems. New records enter into our repository through a few points of origin. The vast majority do come through the user deposit system that collects metadata and files that then proceed through security reviews. There are some miscellaneous records that come through like a share drive that we then harvest, and we also do bulk uploading of digitized assets to their corresponding records. And again, all of this is mediated through API calls made to the orchestration layer, which then deposits the repository. And there were several services downstream that also needed new workflows created as well. We had an internal search UI that was tightly integrated with the legacy Adore repo, which completely required replacement. We have experience running Blacklight instances, but the team was actually hesitant to use it for our new UI. Our team has limited experience with Ruby on Rails development, and vanilla Blacklight lacks some of the needed access control features for the laboratory. And when we had done customizations for Blacklight instances, we often had trouble upgrading to new versions of the software. Since we're much more familiar with PHP Laravel, we decided to create an entirely new system leveraging our team strengths. So it's basically a Blacklight application written using Laravel with an otherwise similar tech stack. For external services, we did end up deploying a rebuilt static Blacklight instance to serve out a subset of environmental regulatory documents that need to go out to the public. We also created new API services for deposit to DOE Austy to comply with federal mandates and laws, and a new stored deposit process to Xlibris Esploro, which enhances our availability of our open and published research. So showing what these systems actually look like, here's an example record from our user deposit review and release system. It collects your standard metadata, like your title, author, purpose, and type, but also things that are more specific to the laboratory, like specific intents and subjects that you see here. And this is our orchestration layer UI, the Laravel app we built to manage our overall ecosystem. You can see, we see the user submission here and how it's tracked in the system. So there's various different versions that have gone through, the various different things like the statuses, dates, times, IDs. These are all tracked, and they're also all searchable. So if we need to go track down what happened with the record at any point in time, we can find all the actions that had taken place with it. And this is what it actually looks like in Dataverse. We have some standard out-of-the-box metadata, but this entire block kind of opened up here is all custom that we built based on specific needs of our systems and then documented in our metadata application profile. And this is our internal search and retrieval system, the Blacklight in Laravel application. It's customized with additional functions for our local needs, but overall does retain the various different search, faceting, and other features familiar in Blacklight. And since this example document is an environmental regulatory document, it also needs to be made available to the public and synced to another system on a different network. So our orchestration layer recognizes this and has placed it in one of our holding pens and sent out notifications to the environmental compliance folks to make a decision for release. And again, our system tracks all of these actions. So once designated for release, the document is automatically sent via orchestration from Dataverse to the static Blacklight site on another network for access by the general public. So just a few final thoughts and lessons learned from our repository efforts. Really, the repository investigation and evaluation project was a key component of our success. Having a simulacrum of a production project illuminated much about the actual implementation work, the team commitments that would be necessary, and the requirements for an overall architecture. It provided clarity that our repository could not be a one-size-fits-all solution, a significant roadblock encountered by past replacement teams. Dataverse was an essential but not sufficient component of our repository replacement work. Our orchestration app does most of the heavy lifting, directing and tracking assets between systems. Whereas our prior paradigm was that the Adore repository was the central and indispensable system, we purposely designed our new ecosystem so that every piece was mutually exclusive to the other. So it was feasible to easily swap components as desired. It is possible that we evaluate again and in a short period of time replace either the core repository or other components with completely different solutions. We have already modified processes and added services to our orchestration layer and other external integrations since going live in July of 2024. So beyond just replacing our repository infrastructure, this project really laid the foundation for a flexible, scalable ecosystem capable of evolving to meet future needs. So just another shout out to my team who did the grand majority of all of this work, and be happy to take any questions or comments. So thanks.
Okay. Helps when it's not muted. So any questions for Ryan, just throw them in the Slack. Now we have John Page and Mike Kosteluk with Bots Behaving Badly, How We Learned to Tolerate Crawls Without Losing Our Minds, for a 20-minute talk.
Okay, cool. Can you hear me? How do we do this part right here? All right, cool. We can go back. All right, I'm John Page. I'm also first-time attendee at Code4Lib. I'm here presenting on bots behaving badly with my colleague Mike Kosteluk. How we learn to tolerate crawlers without losing our minds. We're from NC State Libraries. So we're all familiar with occasional web crawling or denial of service attempts. Those aren't new. But a couple of years ago, we started seeing something different. AI-driven crawlers entered the picture, emerging like the Terminator in our meme. They were distributed across lots of IPs, making it harder to spot them right away. Each IP made only a small number of requests, but collectively they created a significant load on our infrastructure. These bots weren't behaving like traditional crawlers. They targeted deep or nonsensical facets of our data, issuing many expensive queries that strained both our app servers and databases. We had to quickly develop blocking techniques just to keep up, but also we needed time to figure out our guiding principles. So enter the bot blocking brigade. The BBB was created as a sub-team of our web infrastructure product team, consisting of myself and Mike, Eric Olson, and led by our chair, Adam Constaberis. Before diving deeper, just to give some added context, our infrastructure is hosted locally, and a hardware load balancer is used to distribute network traffic among our servers. In total, we are a medium-sized team consisting of about 3 sysadmins, 15 developers. We manage about 80 apps. The brigade had a dual mandate. First, we needed to identify unifying principles for policy development, And secondly, we needed to give guidance to our developers and sysadmins. To address why we wanted to first identify unifying principles, I should say that within our library, there were generally two views on how we should address these bots. Some wanted to just ban all the AI crawlers on principle, but there were others who expressed, again, generally speaking, that this is new technology, it's the future, we have to play ball. So we had to decide if on a matter of principle, we want to block all these bots, single out particular companies, AI companies, companies that we believe are doing things that are counter to the library's mission. We looked at what we had within the libraries in regards to our access policies in terms of use, and we didn't find the guidance we needed. And so failing to find an initial agreed upon principle of good versus bad bots, just to get a clear picture in our heads, we worked through a classification of bots according to their purpose. So while not quite Linnaean, our taxonomy showed bots can serve a multitude of purposes. They have some valuable purposes like powering search engines. I guess those are valuable. They're not a mistake, for sure. They assist researchers gathering data. They can perform accessibility checks. They can also do security scans to improve security practices. They can also be used for not so valuable purposes like scraping and reselling copyrighted material or DDoSing our sites. They can also be used to train LLMs. So banning bots based on assumed purpose faces an immediate problem, though. How can you tell what purpose a bot is serving when they are crawling your site? Not all bots are created equally, which can lead to gray areas in determining purpose. So bots are expected to identify themselves via a user agent string. So this is closer to a social norm than it is to an internet standard. Here we have Agent Smith as a metaphorical user agent to illustrate our points. Most bots run by well-known entities will typically identify themselves via stable user agent strings that they publish so that we can easily identify them. But it is also possible for a crawler's operator to outright lie in the user agent string, specifically to avoid detection as a bot, and it's possible for an entity to publish the user agent string it uses, but then change it over time and at a rate that effectively confounds attempts to block it. There are legitimate reasons for a bot to pretend to be Chrome or Safari to see if a site delivers different content to users of different browsers, for example. So, to conclude, this didn't really help point to a solution to our dilemma. So we took a step back and looked to our fundamental library principles for some guidance. We started looking at the ALA Code of Ethics and Guidelines for Library Policies, which was useful, specifically the guideline that library policies should not target specific users or groups of users based upon an assumption or expectation that such users might engage in behavior that will interfere with the achievement of substantial library objectives. So approaching this from a perspective of principles of librarianship also got us thinking about what a physical equivalent to AI, to crawlers in general, or these AI-specific crawlers might be. What are some physical analogies that we could look at? So if someone checks out all the resources on a particular subject, then returns the items on time so that another user can use those resources, we don't deny access to that person. We generally follow a principle of not denying access to users unless they prohibit access to others. But if the patron who checked out all the resources, instead of returning them on time, tossed them into a dumpster fire, that patron might be denied access in the future. Likewise, to call to mind a different library service, checking email versus running a BitTorrent client on a public access computer, or printing a document versus monopolizing the printer to run a small business. We have policies in place to deal with these situations to preserve access to all our users. Another concern, specifically with LLM crawlers, is copyright abuse. Specifically, in our case, should we block bots that have a history of copyright abuse? But after a discussion with our resident expert on such matters, Will Cross, who serves as the director of the Open Knowledge Center and head of information policy, we came to the understanding that our current copyright statement places the burden of ensuring compliance with the intellectual property laws on the users of our sites. So ultimately, we care, but we're not responsible for what other people do. And again, we don't proactively prohibit access based on what we think someone might do with the information that we provide. It's on the copyright holder to enforce copyright. So as Lionel Hutz would say, no further questions. And so we arrived at our general principle. The emergence of machine learning or AI crawlers does not fundamentally change our approach. If content can be provided without impeding access for core audiences, it should be. While we might categorize AI crawlers differently, this should only be based on bad behavior, such as excessive crawl rates that degrade service. The key concern is excessive load. Rather than restricting bots based on their operators, our policies should focus on identifying and mitigating bot activity that strains our infrastructure, using rate limiting or blocking when necessary to ensure reliable access for all users. So now that we've covered what our general philosophy is, now we can get to the good stuff. We want to sketch out how we're starting to implement these principles and what we've learned that might help others. So one of the most basic but useful changes we are making is to start following some consistent practices around using web crawler directives, including robots.txt and sitemaps. We were already using them, but in a scattershot way, particularly for our website and high usage apps. And where we did employ them, they were probably created a decade ago with a search engine optimization in mind. So compared to search crawlers, we've seen that these new crawlers are far more aggressive in stringing together facets and attempting to download every scrap of content they encounter. So more robust directives are called for. But of course, as we've seen, most bot swarms, they simply ignore those things. One thing we like about implementing these, though, for our apps is that if we detect that an IP is accessing our site in a way that is contrary to our stated directives, we have no qualms about blocking it. It lets us skip past the whole, is this a bot or a human determination, because it doesn't matter. They are not respecting our policies. So the next step is, how do you identify excessive load? So as we said, excessive access equals impacting service to others. So we need to be able to determine if that's the case. So some of the metrics we use to measure service availability are average site response time, error response rates, CPU usage, shared resource usage, available disk space. To know whether any of these metrics are abnormal, we have to know what normal is, and that's going to vary for each app. So we need to establish baselines for key metrics for all our apps. Then we can set thresholds for when an app is performing significantly off from the baselines across one or more metrics, and when those thresholds are crossed, we'll send an appropriate alert. Knowing is half the battle. So when you think you have bots that are ignoring your crawler directives or creating excessive load, it's time to block them. But how you do this is going to depend on your stack. Like for those of you in the cloud, this might look very different. We'll share a bit about how we do it in our on-prem load-balanced environment. The first step is identifying the troublemakers. Depending on how we detected the issue, this may be readily apparent or may take some serious investigation. Often we need to take a gestalt approach. We analyze request patterns. Are there IPs issuing deep, high-cost queries that normal users wouldn't? Agents ignoring robots.txt and accessing parts of the site that should be off-limit? We can check user agent headers. Some bots try to blend in but leave subtle fingerprints that give them away. For instance, Chrome version 60. If an IP belongs to a cloud provider like Tencent, OVH, AWS, or Azure, that's a potential red flag. Again, not one of these things that I just mentioned is a clear signal. You sort of have to take a whole approach to identifying these. So once we've pinned down what the bad IPs are, we can block them. But since we are dealing with thousands of bots from data centers, We've had success banning by CIDR or ASN, which stands for Autonomous System Number. It's a number attached to a group of networks operated by a single entity. And this allows us to block thousands of IPs distributed over a CIDR range in the same ASN. So tools like MaxMind's GeoIP database or IP info can help us look up that information. To further illustrate our approach, here's an example script that I've recently been using. As we said, we have found that grouping IPs together by ASNs is an effective strategy for blocking. So using bulk ASN IP range data from IP info, the getBots script processes an Apache log and clusters together IP addresses if they fall within the same ASN IP range. It outputs the total requests per range and also tries to calculate the total IPs per range, and it tries to calculate how evenly distributed those requests are amongst the various IPs using some statistical measures like standard deviation and coefficient of variation. This is kind of a bad example because this is ChatGPT, GPT bot. Most of the time, and they usually only use about one IP per range. Usually you're going to see like 1,000 IPs, and the total requests are going to be in the max request of what we call the worst offender. So the worst offender is the IP that has issued the most requests out of this range, and usually that's going to be much lower, and that user agent array is going to be filled with strings of different user agents. So we look, like we said, we take a Gestalt approach, so we're looking at user agent strings. We also normalize the request patterns, so we look for particular patterns, as you can see, that had most common request is the normalized request pattern, and it was 685 over the course of about 2 hours. So you can see that that's clearly crawling the site. The script also outputs the smallest CIDR range that would capture all the IPs in the ASN range for blocking purposes, so you're not blocking purely by ASN range, because that could include millions sometimes, millions of IPs. So when you're facing bot traffic like this, the impulse might be to handle it directly in the app. It makes sense. It's easy to implement a sophisticated solution there. But with a team of 15 developers managing 80 different apps, that approach quickly becomes a nightmare to maintain. Not all of us are Neo. A better strategy is to move the blocking to the edge of the network. This could mean handling it at the web server level, which is good, or even better at the load balancer if you had one, if you have one available. For us, using a hardware load balancer made blocking traffic across all our apps much more manageable. It helps protect the heliosphere of our apps, so to speak. So if you can see, collection guides and citation index are two of our apps, and there's our library website, and the load balancer is blocking the bot swarm. The right approach, though, depends on the volume of activity and the number of visitors you're managing, and the number of applications you're managing. Lower tech solutions can work initially, but can quickly become unwieldy as the traffic grows. And with all of this, monitoring and adjusting is essential. Having said all that, I want to now talk about our plans for improved system stability. So we've already been implementing crawler directives, working toward establishing baseline performance metrics, corresponding alerts. So now let's give you an idea of some of our future plans for improved system stability. There are some tools we want to explore. First, we can start off with tools for our developers. We want to refine robot.sot text templates with tips on how to block some or all bots from some or all of the site. We want to continue to use and improve our scripts to help identify IPs causing load. So that script that I just mentioned, it normalizes the request patterns for the worst IP of the range, but it would be better if it normalized request patterns for the whole IP range in that ASN. We also want to investigate best practices for system performance. So we want to understand application bottlenecks better. We want to understand our app dependencies better. We want to investigate circuit breakers. that give you a chance to turn off nice to have but not necessary features, to give you a chance to react quickly to excessive usage, especially with microservices and apps that depend on other apps. We also want to install Go Access on all of our servers and become familiar using it. Go Access is a tool that can provide a quick overview of recent web server activity from the command line. And we're also looking into using something like a turnstile, with Jonathan gave a great presentation on yesterday. And shout out to Joe Coral's work on that. We want to use that with some of our blacklight applications that support multifaceted search, those with catalogs that have a tendency to trap these bot requests because they have an unusually large number of URLs. So we're also looking into some system tools, some log aggregation tools like ELK or Splunk. So ELK stands for Elasticsearch, Logstash, and Kibana. And we want to use that tool to create monitoring dashboards. We also want to eventually move all of our web apps behind their load balancer and investigate the web application firewall feature of that load balancer. Another thing we want to do is to further support good actors. So I'm thinking of researchers here. So we're working on a terms of service that states something along the lines of, like, if you want our data, get in touch with us. Let's see if we can provide you with what you need in bulk. Instead of you having to scrape our sites for that information. So to recap, the gist of what the Bot Blocking Brigade learned, starting from fundamental principles, can help you develop a strategy that suits your own unique needs. We spent time finding out our guiding principle, which can be stated as bots aren't good or bad, but breaking our site is bad. Again, our implementation will probably be different from yours depending on your stack. And this is a forever changing arms race, so what I said today is probably might not be relevant in a year. Things change quickly. If you're just starting to face this problem or in the thick of it now, there's no better place to learn more than the Code4Lib bots channel. So if you don't take anything away from me today, just take that. Join the bots channel on Code4Lib. You can learn a lot in the bots channel, even if you just lurk it like I do. But get involved and we can collaborate. Thank you.
Thanks, John. And now, for the last talk of this block, we have Marina Fisher with a 10-minute remote talk on transforming museums and harnessing the power of digital technologies. Marina, could you speak so we can make sure we can hear you?
Hello, everyone. I hope you can hear me.
Yep. Take it away.
Well, thank you so much for having me. I am talking from University of Calgary in Canada. And thank you so much for allowing me to share some of the information that I have gathered and played with over the years. I would like to talk about technology, especially like digital technology, on a wide spectrum, from something that is easily available maybe to everyone and some things that are not available still to smaller libraries or smaller museums. I work in a big research library, and the museum is located in the library, which is called the Libraries and Cultural Resources at the University of Calgary. We work very closely with the archives and special collections as well. So we are also really lucky to have a lot of tech support, a lot of great funding that supports our tech. But as I said, it's been a really long journey of learning, and I would just like to share information for, like, as I said, from wide array. So I will start with the simplest and the most easily accessible stuff, and which is photography. However, we sometimes underestimate photography and what we can do with some really, really great cameras and great skills. And I just wanted to show you, like, I work specifically with the ancient coin collection in the museum. And we had all kinds of images that we scanned over the years or photographed with not really great cameras. So the last few years, we've been working on updating our images. And what you see here is our photographer taking photographs in this black box or photography box that I just purchased from Amazon for $100. But it is absolutely amazing and produces great images, which I will show you. Another great tool is microscope camera, which can also produce really detailed and close-up images. But so here, just a couple example to demonstrate what I'm talking about. And we have received great feedback about our new photography and the images that we provide for free for research and even publications. I also want to say that there's so much more that we can do with photography. Like we do something which I call artsy images, and that is to look at and present the artifacts in ways that is not maybe conventional for the museums and for the libraries to engage all kinds of audience. And this is one of my favorite images when we played with M&M candy and ancient coins and trying to show the different size and how they relate to each other and the color and so on. And here's another one. This is a Canadian quarter, which is, I believe, the same size as US quarter, and just a bunch of coins, ancient coins on top of that one. The next one is Canva, which many of you are familiar with, I'm sure. But I want to show you there's so many different things we can do with Canva. And the best part of it is that you can do a lot of it with the free account and also with the paid account. I have both. I have my own account that I use without any subscription, and then we have the library account that is subscribed to all the fancy features and has all of the capabilities. But I am quite familiar with what can be done with the free account, and that is a lot. So we can do 360 virtual images of galleries or libraries or anything. I have a link down here below. If you click on any of these bubbles, they will either take you to a different site or give you some information, or they will zoom the photos and so on. There are all these in Canva, the free online video editors as well, so that can be used with a free account. And a lot of wonderful videos can be created, like about procedures or artifacts or other things that are available. Regarding the brochures and posters, I've been working with this for many years, trying to understand how we can do this the cheapest possible way. And Canva is truly incredible. You can also design something there by yourself, and then you can have it printed and delivered to your address for just a couple of $100s. Like I've done many brochures and they look absolutely spectacular. The next one is the ThinkLink, which is this incredible tool. Here's the address, thinklink.com. And this is from the University of Calgary Library that our incredible librarians have created, how to explore this, the library, virtual orientation. You can click on all of these active bubbles and links, and they will give you exactly what you need. And it's really fun to work with and being able to navigate without leaving the site. And it's just visually very pleasing. That can be done for the museum collections as well. It can be done for museums on site. It can be done with special collections and so on. The same thing here. If you click on the loop, it will take you to the close-up of that particular image. And the last thing, which I will talk about, the 3D scanning, We can scan all kinds of artifacts that are in our collection, and we can link them through ThinkLink to our website or images, or we can even post them to some other free websites that I will mention. The next one is RTI, reflectance transformation imaging. And this is a really interesting technology. I started with that in a very, very low-tech environment, trying to understand how it works and what are the outcomes and the results that we would get. So what you see here in this slide is just using the regular camera. It can be anything really. And there are certain ways you create like images, like about 60 images of an artifact with exactly the same distance. That's why we're using this this rope here. So we're measuring the distance and then we're doing it from all different angles. You can also do that with high-tech RTI domes. And we have recently purchased ours. Here you can see. And if anybody requires further information about how to do this or where to acquire their dome and costs or anything like that, please feel free to reach out. I will be very happy to share that information. There are lots of articles that are published on this. Even though it's still not a very well-known technology, I've seen it in some libraries actually available in public spaces that visitors or students can come and they can play with it, learn how to use it, and so on. So essentially what it does is when you create like all of these different photographs of the artifact, and by the way the dome works is it takes sequential images, so in sequence, hundreds of photos with different light as it travels through the dome. Inside, you can see those little silver dots. Those are the little tiny LED lights. And it does that in a second versus like if you do it manually with a camera. Nonetheless, the results are pretty much the same, just take a different time and effort to do it. But generally, the way it works is that there's this free software that you can use, and then you upload these images, and you open them in the software, the RTI viewer. And if you go to this like green circle right here, which indicates the light, the source of light, you can then move through the object from different angles and read the artifacts in a way that cannot be done with photography or regular other technologies, or even just with our own eyes, or even loops or microscope cameras. This is really incredible tech, and we've been able to read inscriptions on coins that we never knew they existed for relatively a small cost. And then the 3D scanners, as I mentioned, the 3D scanners, there's so many on the market. And I do have to say they're quite expensive. The Artec 3D, I think it's about $50,000. There are other ones that are even better, and they range like around $100,000. So for some places that can be quite a lot of money. But if you are located at the university, you can collaborate with different departments, like usually engineering departments or faculty of engineering. They have all kinds of tech that may even be available for public use or for other departments on campus. So I work with ArcTech, with Department of Engineering. They were even very kind to scan it for me. I worked with simpler 3D scanners in the library that I was testing to see what kind of results we can get. So even if there is no necessarily funding to purchase one, there are ways to scan the artifacts and then just use the files and continue working with the files. If anybody's interested in more information about the 3D scanners, I'm happy to share that information. This is the first scans we did with one of the scanners in the engineering department. And what happened is that right when we were done with all the scanning, we realized that the 3D scanner the engineering department had did not necessarily have ability to capture texture because that is not a feature that is necessary for their work. So essentially what that means is that all the artifacts were blue. You can still see the details are amazing, but we actually also wanted to capture the texture of the artifacts. That can be done. We've added texture to some of our blue files, as I call them, and they're really magnificent. They just take some more time. Or obviously, if you have a better tech, if you have the higher end scanners that you check all the features that are available, that have the texture that is embedded immediately, the texture files are embedded immediately and applied to the image, you can come up with some incredible images. The Sketchfab is a great website where you can post all these large files. If you don't have place where to store them or how to link them to your institutional websites or library website or digital deposit, whatever it is that you have, you can first start with the Sketchfab and you can upload and share and promote the amazing images and the artifacts that you have and that people can use for free for educational purposes. The last one I want to talk about is the virtual exhibitions. We've created quite a few of them. This is the website, the URL for the link where we keep our virtual exhibitions. And the ones that I have created here in the slides are in Microsoft Sway. Unfortunately, Microsoft Sway has stopped developing, or Microsoft has stopped developing the software. They still host all of the virtual exhibitions that were created there, but at this point I am searching for another software that is hopefully free that can be used for all kinds of purposes. Microsoft Sway was free. It was limited, but it did create quite incredible exhibitions, and you can like move through them in beautiful ways, and they allow all kinds of interaction with the database and or with the exhibition and so on. So this is the view on the user end, how like these are just a few ones that I've created and how they look like. It was very, very simple to make. And as I said, I am sad that Microsoft is shutting down Sway, but I am hoping that there is something else out there. And if anybody else knows about any other great software for virtual exhibitions, I would be very happy to hear about that. So this is my email and my X or Twitter handle. I like to share different texts and ideas and exhibitions that we do. So feel free to follow or feel free to reach out. I would be very happy to connect with you. So thank you very much.
All right. Thank you, Marina. And that is all of the talks for this block. So everybody now gets a 15-minute break. Be back at 10:15 for the next round of lightning talks. If you have a lightning talk and you need to drop some sort of PowerPoint or various presentation thing on the computer, come up now during the break. Also remember, no presenter mode. Now it's time for lightning talks. So we're going to start with Heather Greer-Klein on OSS and the rot economy.
There you go. Hey, everybody. This lightning talk is a benefit of open source, sort of a different way of talking about this benefit. It's been rattling around in my head. I thought it would work well as a lightning talk. First, I have to talk about what is the rot economy. The rot economy is a term that was come up with by one of my favorite technology writers, Ed Zitron. It's a way of talking about how the markets have become entirely decoupled from the concept of what good business is. There's one truly noxious metric, and that's growth. Growth, number go up, that's it. Here's a little story of the rot economy in action that's affected everyone in this room. February 2019. Ben Gomes is Google's head of search. He's been a Googler for 19 years. He's part of the team that built the foundation of modern search engines. Pravigar Raghavan, management consultant wearing an engineer suit is what Ed calls him. He's Google's head of ads. The ads team calls it the highest priority type of company emergency at Google because search query growth is significantly behind forecast. And Ben says queries is a bad metric to measure search. It would be better to create compelling user experiences that make users want to come back. Now you can see all of this go down in emails that were released as part of the US Justice Department's lawsuit against Google. It's chilling stuff. I recommend you check it out. So fast forward to May 2020, Google has rolled back search improvements dating back to 2012, including unsuppressing everything they'd put in place to prevent spammy results, completely changing how ads display, and addressing that pesky little query issue. And what is the result of this? Well, Pravigar Raghavan is moved from head of ads to head of search. And Ben Gomes is moved over to Google Learning, where he will never again get in the way of the money. So this relates to open source to me because open source is built for and by the people who care about the tools. Open source is a way that we defend against the rot economy. And we don't have, search or we don't have ad-driven competition, but we sure do have private equity. And we sure do have rot economy thinking about number go up, growth at all costs. And this came to mind to me when I was talking to someone last year who said they were dealing with an old repository system, didn't have enough staff to update it. And he said, we'll probably end up with whatever repository software Ex Libris throws in with Alma. Heartbreaking. Because what do I immediately think of when I think of software that is thrown in with other software? These wonderful tools. Teams and SharePoint. These are not tools that were built for and by the users. These are tools that were thrown in to add value, to make number go up. This is growth software. So in conclusion, Pooh says, don't select critical infrastructure that was created as a rot economy growth hack package deal. Thank you.
All right. And next up, we have Maccabee Levine with ProQuest Heart EBSCO.
Yeah, this didn't fit on the piece of paper, but I'm going to call it, Why Can't We Be Friends? EDS and ProQuest. I'm not going to sing it for you, don't worry. So last year, I presented here a poster on a single search system that we built for Lehigh using Viewfind. And so, of course, we had an articles box for however long we had it. But now we have a bento situation with an articles box as well. Our articles box feeds using the EDS API, so it should really be called the Some Articles box, whatever EDS includes. We do have other stuff, like from ProQuest. It's not here, but we have it. You know, maybe that's a problem. So what's the lightning talk round history of this issue? More than a decade ago, Library Journal, two of the largest competing vendors, EBSCO and ProQuest, both provide content and a discovery system, but neither helps the other populate the central index that underpins their respective discovery products. EBSCO tells one of the academic libraries, well, it doesn't matter. EBSCO indexes much of the same content themselves, estimating over 98% of the same coverage. So maybe it doesn't matter. ProQuest even sort of agrees with that. Their website says not indexed in full, but some collections are available. Okay, but EBSCO also says there's no substitute for the index itself, while other services may attempt to convolute this issue by inferring they cover a certain percentage of the journals. Don't believe it, doesn't matter. As of 2015, Marshall Breeding reports EBSCO and Ex Libris currently remained deadlocked. But that was a decade ago. So much has happened since then. Things are so much better now. Right. I don't know if anything's happened. EBSCO, credit where credit is due, they sort of revised their policy a couple years ago to say, okay, let's try to have a little bit more open collaboration here. Maybe something resulted from that. If so, please say so in the chat, because I'm not entirely clear if anything did. So, thankfully, Code4Lib friend here, Jonathan Ruckend, mentioned a decade ago, and I discovered a year ago, there's an API in ProQuest, right? We can get their data via API. And we use an open source system, ViewFind, so it already integrates with EBSCO. Why not just build in some ProQuest integration there also? So one pull request later, we can now get ProQuest data into ViewFind via that API. And so here would be an example screen of just ProQuest data coming into a separate tab within ViewFind. Yay, open source, problem solved. Okay, maybe, what do we do with that now that we've got ProQuest integrated also? We could use ViewFind's blended search feature, which is essentially a zipper or more complicated algorithm for just combining two search backends in one. It would be an example of what that could look like. You can see that the odd numbered results here for this search on tumbleweeds are coming from EBSCO. The even results would be coming from ProQuest. We would have a sidebar here where you could limit to which provider you wanted to actually see the results from exclusively, or a merged facet of databases, and that's fine too. But remember that 98% of the same coverage claim? In theory, then, we have a lot of duplicate results. That seems like a problem. Also, EBSCO gives us a lot of different facets. ProQuest doesn't. How do we resolve that in a blended situation? Do we show the facets that only apply to EDS? Do we not? Not a great solution there. Should we just had yet another box of ProQuest stuff? It's a solution. Should we have a main EBSCO results screen, but just have ProQuest stuff in a sidebar? Should we break up ProQuest stuff? Everybody really just wants the dissertation and theses, maybe. Is that the important sidebar? Do we pull out 2 or 3 ProQuest data sources into separate sidebars? I don't know. What's the answer to this? I kind of want you to tell me, because we're exploring this, and this is a lightning talk, right? I would pretend that there'd be a real answer if I had more than 5 minutes, but I don't. We're exploring this. Please, give me some ideas in the chat. Has this relationship between the vendors gotten better? Like really gotten better? Please say so in Slack. Do you have suggestions on what the best way to include these ProQuest results? I'd love to hear that. People don't know there's a great Slack channel on the Code4Lib workspace, local discovery layers. That's good for discussing this stuff also. Thanks very much.
All right, and next up we have a talk on Folio API integration project, Redbud. We don't have a name for that, so whoever's doing it, please come on down.
Yeah, another folio thing. another folio API integration, another folio API thing. I'm Oklahoma State Universities, and I'm David Pereira. So in 2000, end of 2023, OSU libraries start migrating from Alma to Folio. And during that time, we found there is a need for user integration systems between Folio and the OSU student information system. And at that time, I developed a script file to read the CSV file and put those, read the CSV file and using the Folio APIs, put the user details into the Folio databases. And during the 2024, the circulation needs some reports based on their Alma experience. So at that time, we decided to cater all the future and all the requirements to develop an application and name it as a Redbud application. Redbud, it's kind of a web application. So there is two types of things happening on that Redbud application. So there is daily schedules. So read all the circulation data and put those data into our analyze, and only the data we need to put into those reports we are putting into our databases. It's kind of daily schedules processes, like do you guys know about cron jobs? And those are kind of scheduled jobs. And user detail integration also kind of a scheduled job. It run around 1 a.m. at every day. And there is also a manual process, bulk editing capabilities, because of Folio API is providing the bulk editing capabilities, and sometimes we need to extend the user's expiration date. So then those kind of things we are doing manually. And the second part is report, displaying all the data we collected from the scheduled jobs. And right now we have several reports: loan report, overdue reports, and record count reports. So I will show you kind of a live demo. So this is the application. This is the web application. Basically, the settings is kind of the processes that we are running daily, and manually we can run those processes. Kind of there is a manual process. We need to extend the semester loan due dates based on the user group kind of processes. So I group all the things, some circulation databases kind of things, some cron jobs. Those are scheduled jobs. And these are the reports, overdue fine reports. So those are some reports are directly calling the API and collect the data and displaying this kind of. So it will take some time because they accessing the API and then get the data. And some reports are already access the data and put those analyzed data into the database, kind of this kind of institute counts. So some of the circulation request to display all the counts of the instance holdings and item count. Those kind of things are the other features in this application. I like to invite any developers who like to engage with developer of this tool. Please contact me. My email and my QR code for the contact details are here.
Thank you. And now we have Jennifer Stubbs with CV of Failure.
you hear me all right? Closer. Hello, I'm Jennifer Stubbs. This is my lightning talk on a CV of failure. I can't use my initials JS because that's JavaScript, and I can't use the initials my mother gave me because that's JAW, and now AWS is a thing you guys say a lot that I don't know what it means, and so I'm gonna own that my initials are JAWS. So what is the origin of the CV of failure? Dr. Melanie Steffen of Edinburgh at the time wrote a editorial, not really an article, in Nature in 2010, elevating the importance in research and scholarship about highlighting all of the things you do, the contracts you attempt, the fixes you make that aren't celebrated, the grants you apply for and don't get, the proposals you make and you work on and they go with another vendor. That is how you become who you are. All of the work that makes you succeed should not be hidden under a rug. It should be celebrated, especially with new career people and our students, because they think it's 5 straight A's and your first job. They don't realize how we're all on our 3rd or 4th career choice in a 3rd or 4th location with a 3rd or 4th employer. So the connection for me was I first heard about it when someone who at that time worked at, I realized, this Princeton, Dr. Johannes Haushofer, who's currently at Cornell, and admits that he was not the first to come up with this idea. It was Dr. Melanie Steffen. He's just the one where it's his most cited work, and he'd kind of like people to cite his work and not his Vox article on his CV of failure, that there are all of these other examples that, as with the rot economy, only one of those 4 still live on a not 404 page. And my CV of failure was that first photo. Can I go back? I learned about it when I was at NYU Shanghai, and the students asked for International Women's Day. This past Saturday was an anniversary. For women, show us who you are. How can we follow how you got to where you're at? And I had been practicing Chinese and learned the phrase fried squid in Chinese is the idiom for fired, a pink slip. I haven't technically been riffed, but I've been encouraged to find other places, or my contract wasn't renewed, or it's not you, it's 2008. We're sorry that your 2-year internship is being terminated because you're just the most recently hired. So there's a link to the start of my CV of failure as part of the image in the slide. And it just shows how I keep track of stuff maybe I want to go back to. How do I prioritize stuff I was doing for other people and things that I've grown from? I have a short meditation called Be Water. It's about maintenance. You can build a stalagmite. That's how water does it. It slowly dribbles through the cracks, collecting a little bit at a time. And eventually, you don't want to let go because you don't know what's below. And sometimes you have to and you fall, and you don't know how far you'll fall. And at the bottom, you'll find a whole lot of other people who have fallen with a little bit more like you, and eventually all of you have made a huge difference, a great and mighty stalagmite. Sometimes as water, as we mentioned with the river that you dip into and out of, you're slowly eroding a boulder into a smooth pebble. After all, it's how we got the Grand Canyon, this huge space. It's the space that catches us and the maintenance of making that space with time, a little bit and a little bit. I had 2 more slides, but I'm almost out of time. The key point here is document your no. And this morning I learned whisperings means something to you guys, and I don't know what that means. So I'm adding to my list. But I've also learned that documenting all those no's of, we don't do that here, we can't do that here, we stopped doing that here, that's not available right now, that's not available to you. You don't have permission to access that. Helps me collect evidence to build a cost-benefit analysis of the time it takes me or a supervisor to work with someone else's supervisor or their most recent hire to do a data pull that everybody else just does in Tableau or with R or something like that. So you explain the need for your infrastructure. I'm not sure about the handwriting. Am I down to 5 seconds? Okay. come talk to me about a carpentry con for librarians. That's how we train. Thanks.
All right, and next up is Stephen Goman with Unexpected Character.
I wish I was paying attention to where everyone was pulling their presentations up on that Google Drive right here, right? Bada bang. All right, so I have a lightning talk for you. It's called Unexpected Character, and that's both a JSON error, and it's also me. I'm an unexpected character. I'm a cataloger. I'm an operational library worker, and I'm at Code4Lib. So I'm going to talk to you a little bit about my messy metadata projects that have brought me here. So for more than 2 decades, my institution has been creating digital facsimiles of special collections materials, and at the point of digitization, creating bespoke catalog records describing the material that's been digitized in a bespoke cataloging system using bespoke systems of describing material. It has taken some influence from MARC, some influence from DAX, but has been beholden to the laws of neither. It's very messy data. And this also means that patrons who view our collection material remotely are getting different descriptions of our physical stuff depending on what system they're looking at. In our digital system, it might tell them one thing. In Voyager, it says another. So we made the decision to deprecate description in the digital library while preserving unique metadata there as enhanced metadata to augment what we already have in archive space in the ILS. And that's going to be a really easy project, right? So the problem is that it's not just moving the metadata around, but it's also how we conceived of digital objects at the point of digitization may or may not agree with the catalog of record in the current era. So I have here a tarot deck, which we digitized at the point of acquisition, and we created a bespoke catalog record for the deck, and it existed on our digital library for several years before an archivist was finally assigned to create a finding aid for it, where they decided to create an item level finding aid. So every card in the tarot deck has its own level of description. So what used to be one digital record with 160 images is now 80 digital records linked to the finding aid. Or what about this? Okay. So this is a map of Surrey. If you ask Voyager about it, it says, I don't know nothing about no map of Surrey. What I know about is an atlas of maps of Great Britain, of which this is one page. So if I were to port that metadata from Voyager into my digital record will lie to you because it will tell you that I've completely digitized this atlas because it was a record that completely digitized a single map of Surrey. So I have multiple sources of truth that I need to adjudicate between in a variety of different metadata sources. I have metadata that needs to migrate from an object level to an item level. I have digital objects that need to be split or merged. And I've got to do that a couple 100,000 times. So colleagues asked me, Stephen, have you considered using ChatGPT to help you in writing scripts for your software? And yes, I have, and no, I won't. Yeah. Right, I think that I'm morally required to exhibit a level of care for my collection, for my profession, and for my planet. And engaging with this software does not permit me to engage in that level of care. This is a little banner that I saw on a Steam game. So it's interesting to me that web developers in the video game sphere are being very public about their opposition to this software for moral reasons. I'd love to see that open up in the library space. I want to be involved in that. So what am I doing about that? That means if Sam Altman isn't writing my code, I got to write it myself. So I have been taking Python classes. I have been stumbling through documentation and OpenRefine in our local APIs, learning different Excel scripts, trying to chunk up our data into digestible pools that I can generalize patterns in and refine my code for, so that my set of several 100,000 legacy data is left to remediate is down to a mere 40,000. It's going very well. It's connecting me with project managers across many different departments in my very large and very bureaucratic institution who I might never have had cause to interact with before. I'm discovering pieces of our API scaffolding that does not work as intended with my new use cases. I'm cultivating relationships with metadata specialists outside of my digitization unit. And so that's what I wanted to talk to you about as a cataloger. This is how you got me. I got to learn how to code. And here I am at Code4Lib.
All right. And next up, we have Matthew Swinehart with Finding the Fun.
I do sort of regret naming it this because after Steven, I feel like I'm probably not the same energy, unfortunately. But I am a software developer for Ann Arbor District Library, and today I wanted to talk about a small little side project that helped me get from saying I'm a software developer at Ann Arbor District Library to a software developer for Ann Arbor District Library. And that, like, I've only been there 3 years, and prior to that, other than being a library lover, I didn't really have any library experience. And this little project, as kind of silly as it was, really pushed me over that edge. So at the Ann Arbor District Library, we're really lucky to have a very engaged community, and we have this thing called the Summer Game. I'm sure a lot of other public libraries have a similar thing. It's not, for us, it's not just a reading contest, it's a whole bunch of things digital in the community. It allows us to hide a whole bunch of actually really useful approaches to data in this game. And that's what I did. This last year I decided I wanted to make a connections-inspired game based off of our catalog items. Early 2020s, New York Times games, very hot right now. So just 8-bit entirely, and it was fun. It really connected me to a whole bunch of the staff across the organization, not just librarians, but especially librarians, because we had to create 296 rows for 74 days, which doesn't, at the time, it didn't seem like a lot, especially because we have 800,000 circulating items, but it ended up revealing a lot of the issues with discoverability and the intuitive links someone might make to an item. Trying to find those 4 items within a row that should be related. Desk clerks and librarians would always come up to me actually, this isn't showing up correctly. It ended up being this excellent bite-sized use case for understanding what discoverability, how discoverability was just completely not working for us. It was made worse by the fact that we had to narrow circulation parameters, so scarce items wouldn't show up because it surprisingly did move items, people put holds on items a lot that showed up in these. And I had something else to say here. Anyway, gonna move on. So essentially this game just really is what made the gap between where I tend to work, which was on the Evergreen API, and then associated app level, between the mess that me and the rest of my IT-oriented team was kind of making of the metadata. There's if you ever see a software developer on your team new, and you're discussing with them, and it's just blank stares, just talking right past each other. Highly recommend looking into a very small side project and make it fun, and just find that fun somewhere for them to respect the metadata. I know at a certain level they should just do it, that's their job, but it's a lot easier when you can connect it to something. And that's what this did. From now on, I will be able to much more easily see the problems and make solutions. So I'm not just a person constantly complaining about Mark. I'm a person who has some ideas of how to supplement, and as Beck recommended yesterday, just add things around it without breaking the structure. Previously, I recognize now that a lot of the structures that were implemented below Mark were they just were breaking it in a way that didn't need to be broken. It was interesting. That's my talk. Thank you.
All right, and now we have Eric Morgan with Indexes and Study Carols.
I'm supposed to put this in some sort of mode. I have no idea how to do that. Fine. My name's Eric. Indexes and study carols. I'm having a grand old time reading lots of stuff. How do I make it go to the next page? Oh, that way. I'm a humanist. I enjoy the liberal arts. I constantly ask questions like, what is love? What is justice? What is honor? What is beauty? I really want to know the answers to these sorts of questions. So what I did first is I started creating a collection. I have a collection of about 0.7 million items. There are items from the Hathi Trust, from Project Gutenberg, from early print. There's about a few hundred items collected from OAI PMH scholarly journals. There's a few hundred items from a data set called Cord. So there's about 0.7 million of these things, and I cataloged them all. And they have valid MARC records in them: authors, titles, dates, subjects, keywords, computed summaries, various types of extents. And then I poured them all into Koha. Koha is an unsung hero. It works very well. I poured all these things into Koha, and it does exactly what it's supposed to do. It does it very simply. It does it very easily. This is running on some sort of virtual machine in New York City with 4 cores. It does exactly what it does do, and it does it very fast. And I pay a whole $25 a month for the privilege of having that particular machine. What's really cool about Koha is that it supports a protocol called SRU. All you have to do is turn it on. And what you can do then is send a very specifically shaped URL to Koha, and it sends you back the results as XML, and you can create a thin client that displays search results. This is just the tiniest of screen results, and I got the faceted search going on, and I can see the items on the things. And what's really fun, because all my things are in open access, is that I can click on items and I get the item. No authentication, no access control, just get the item. But what's really cool also with this thing is that I can end up creating what I call data sets. These are structured contents of narrative texts. Once you have a set of texts and then you create a data set against it, you can compute against the data set and do all sorts of very interesting things. This is the beginnings of an example of one of these data sets, and I call them study carols. And once I do these study carols, I can create things like, I can do all sorts of things like do lots of feature extraction, parts of speech, named entities, n-grams. I can do topic modeling, semantic indexing, and now I'm doing some Gen AI sorts of stuff. I can then programmatically create whole piles of these study carols. And so I have about 3,000 of these things. But once I'm done, I can begin to answer my questions, and I can find out what words are near love. And then I can find out sentences that say love is. And then I can see what other words are near love and read about those sorts of things. And I can scale and read about things. I can read collections that are like hundreds of books and thousands of journal articles. And I can find real and true meaning out of these things. But the answers aren't so important as the process of the questions. That's what liberal arts is about. It's not really the answer, it's the process of going through these sorts of things. And finally, I assert that you can do this with your own general collections, your own special collections, or the results of your particular bibliographic searches. Thank you very much.
All right. And next we have Ninh Tran with Enhance Accessibility for Digital Collections.
My first time at Code4Lib, so apologies for being a bit nervous. But yeah, my name is Ninh Tran. I'm a software developer at Minitex, which is part of the University of Minnesota. So today I'd like to talk about a project that we've been working on that focuses on using AI-powered transcription to enhance accessibility Currently, we're only applying this to the Minnesota Digital Library Collection, also known as MDL. So it features thousands of items shared by libraries, museums, historical societies across our state, including photographs, maps, documents, letter, oral history. So these materials capture Minnesota's cultural heritage and are valuable for research, education, and community engagement. However, without transcription, some of these items can be difficult to search and access. So we're looking at this. Our current OCR is using PyTesseract, which is one of the most popular open source Python OCR package. So let's look at how it performed on this document. So even though it's a type document, it's used its different fonts and formatting, making OCR pretty tricky. The resulting text is often jumbled up and it's hard to read, with some sections just completely illegible. Then looking at this one, it's a handwritten letter. You know, it did a pretty decent job, like 70% of the text correctly, but there's some still clear issues here. You can see questionable words, inconsistent characters recognition, and just awkward spacing throughout. So with that, I built a AI wrapper called Transcribe AI. I'm not very creative with the name. So designed to tackle these challenges head on. So it can accurately transcribe type, handwritten, and even mixed text. So adapting to complex layout that traditional OCR really struggles with. So here we compare the result of Transcribe AI to OCR. You can see how the AI outshined OCR, resolving the issues that I mentioned earlier. And here's another very dense and in some parts faded handwritten letter from our collection. You can see how well the AI performs. So how does it work? So the first step that I have to do is pull down images from MDL and do some of the computer vision magic, some edge detection, some Gaussian blur to reduce that noise there, and make the document more readable for the AI. Then we get access to the metadata from the document. And then once metadata is collected, we then built the tailored prompts, factoring in the context, structure, and at the same time, the images are uploaded to Azure. So we're using Azure AI services, is using the OpenAI 4.0 model right there. So this is to ensure the model is visually informed and also contextually informed. Next step is to Azure to process a request, and we will receive a JSON response that include the transcribed text there. Final step is involved human quality assurance. So although it's pretty accurate, we want to make sure that it meets our high standard of quality assurance here. And how does this compare to human transcriber? So we're using this document, which is a building permit from Stillwater, Minnesota. And at first glance, it really is remarkable, you know, almost indistinguishable from human transcriber. In some parts even better. There is specific detail on this page that I want to point out. So the second line on the page says between 4th and ... street. So if a human transcriber is unsure about something, they'll denote it. If an AI is unsure about something, it will make things up. So that's some hallucination issue that we need to look into, but it doesn't happen. It doesn't happen very often. So, but I would say hallucination is a feature, not a bug. So hit me up and disagree with me. I'll explain why. Okay. So here what we observed so far. The transcription is highly accurate with minimal errors. They handle special characters better than the traditional OCR. And with that, we also cover the ADA Title II, So far we transcribed over 12,000 documents. If you have any questions, here's my communication. Thank you, everyone.
All right. Keeping this train moving, we now have Natasha Allen with Flyover Country, DIY music in the Great Lakes.
Okay, I've never done this before, so. Oh. And I literally just uploaded this like 30 seconds ago to this drive, so. Probably needs to be refreshed. Here it is. So, hi everyone. I'm Natasha. Pronouns are she, her. I'm an associate librarian in automation, indexing, and metadata at the University of Michigan Library. I'm also a veteran, Code4Lib, no need to clap. I'm, thank you. I wanted to share a brief overview of a project, side project, I guess. I'm really excited to be leading this year. The project is called Flyover Country. My co-collaborator, Zach, and I are working on creating a multimedia physical exhibit documenting DIY or underground punk, shoegaze, hardcore, metal, and emo music in the Great Lakes region from the 1970s to the present. We are tentatively planning to display the exhibit for a couple of weeks in fall 2025, pending campus venue availability. Cool, that worked. We plan to showcase reproductions of posters, zines, live recordings, and other ephemera with a focus on underrepresented voices in overlooked creative spaces outside of major cities. The idea behind the name is to challenge a perception that nothing worth noting comes from the Midwest. We want to highlight the thriving catalog of art and music within the Great Lakes region. We are including materials from all of Michigan, both upper and lower peninsulas, northern Ohio, and northern Indiana. We want to show how DIY music fosters connection and resilience among marginalized youth subcultures, and we have a larger goal of preserving these materials for the future. Many of the artifacts are at risk of being lost due to the ephemeral nature of this media. I don't have time to get into the technical part of that statement, but I'm sure this crowd understands why. Maybe I'll do a longer presentation next year on our preservation work and its challenges next year if folks are interested. So what the heck is DIY anyway? For the uninitiated, it's simply people taking power into their own hands and using it to better themselves and their communities. You can DIY anything, but today's focus is just on music. It can also look different for different folks, but this is how I've chosen to distill it in the tiny amount of time I have to finish this presentation. So I apologize if you were expecting me to give you a step-by-step IKEA furniture tutorial. I don't think there's any time for that. It is not music featured on DIY network home renovation shows. It is not music that is made by artists or musicians signed to major record labels or their various subsidiaries. Sorry, Swifties. It is self-sufficient. It is artists who record, produce, distribute, and promote music independently without the assistance of a major record label. Indie labels are a different story, but I don't have time. Moving on. It is community-led. This means shows are often booked in non-traditional spaces like VFW halls, skate parks, Grange halls, community centers, church or home basements, garages, and coffee shops. And yes, I have been to and or booked many of my own shows in these places and more besides. It is for the girlies. DIY music provides a space for marginalized groups to create and share art without the historical barriers traditionally present to those who do not fit an image deemed desirable by traditional societal standards. There was a really cool photo in there. I don't know why it's not loading, but whatever. I'll post it later. DIY music has always been queer, trans, non-binary, Black, Indigenous and Native, Latino, Chicano, disabled, and neurodivergent. It is middle and working class, it is fat, it is femme, it is always anti-oppression, and it always anti-capitalist. We've always been here, and we're always going to be here. And the statement goes for the rest of the country, too, despite what you may have heard. And I wanted to briefly shout out Nico Stevens, who I had a great conversation with yesterday and who partially inspired this talk. They reminded me exactly why documenting, displaying, and preserving this work is crucial, particularly during a time when others are actively seeking to erase us and our lived history. Oh, that did work. Good. Ultimately, it's a way for people to build meaningful, supportive communities through art. It is a community I've personally been involved with for going on 20 years now in various roles. I even have my very own DIY band now. We're still pretty new, so bear with us. There is not much up on social media yet. I would not be here with you today without this community. It has played a significant role in shaping the person I am today. And I'm really grateful for the opportunity to put a bit of my professional energy and creativity into something that has been a huge part of my life for such a long time. And thank you for listening.
And now we have Ryan Hedrick with data science courses in ALA accredited LIS programs.
Good morning, everyone. This is my first time at Code4Lib and also my first time presenting at any conference. So yeah, I just wanted to take some time to talk a little bit about a research project that me and my colleagues are working on, which focuses on data science courses and ALA accredited LIS programs. So what kind of overview of the project is, in 2022, we set out to understand the different types of data science focused coursework being offered in LIS programs. And so basically what it boils down to is that we, based on our literature review, we created categories of competency areas. And when we then coded each course, we identified from those ALA accredited programs into one of these 8 competency areas to see which types of courses were being most and least frequently represented regularly in offered courses, so that does not include special topic courses. And so it was all US-based ALA accredited programs and McGill University in Canada. Okay, so how did we identify these courses? So we ended up having to use course titles and descriptions that were available through course catalogs and program websites. And we ultimately identified, after a couple of different rounds of review, 269 data science focused courses across 52 programs. And we had to utilize the titles and descriptions because syllabi was just not a good option. We could not gain access to about half of the syllabi for the courses that we identified. And then even the syllabi that we had, they were so inconsistent in the amount of information that they offered that it wasn't really a good option for the coding process. And then the course competency areas that we developed are based on, again, our literature review, especially a work by Carlson and Company. And so it was 8 areas, with most of them being pretty self-explanatory, except for the last one, which is data literacy. And that's kind of the catch-all for any of the courses that kind of just in general discuss data science, but not necessarily any of the more specific areas. And so these are the results that we ended up with. As you can see, data analysis and visualization courses by and far were the most common types of courses, followed by databases, data formats, and programming. So kind of what those boil down to are courses that specifically taught things like Tableau or Python, SQL, things like that. And you will see kind of very, very far back, you have discovery and acquisition of data and data librarianship and services. So what the results kind of suggest is that we are giving students a lot of training in these tools, but not necessarily giving them a larger context in how to actually utilize these tools as a data science librarian. This coincides with sort of my own personal experience. I got my degree in 2023 from Indiana University with a specialization in data science. And I would agree that I did get a lot of training in Python, SQL, data mining, things like that, but not necessarily a larger context as to how I would apply these tools as a data librarian. It's something I've kind of picked up on the job as I've been going and kind of relying on my colleagues to help out. So definitely something that needs to be looked at further as far as how programs can kind of support these tools and give them larger context. All right, thank you.
All right, next we have Ray Schwartz with Project Gutenberg Mark Records.
Excuse me. All right, here we go. All right, folks. Project Gutenberg. If you recall, they did have Mark Records service about 10 years ago. The service was broken when they restructured the database, so the scripts didn't work anymore. But as of last Friday, we managed to pull that together. We wrote a Python script to pull that out. If you're not aware of what Project Gutenberg is, they are free ebooks that started from 1971. And obviously, if you're looking at Mark Records and if you have any questions, you can email me or Eric from Eric Hellman about that. But we'll talk about how this is done. It's generated weekly from a Python script. So essentially, every Mark record is recreated at that point. We don't include the non-textual items. These are just strictly textual records. No audio file records, no data set, no video, no audio books. There are very few of that collection, probably just over 1,000 out of 78,000 records. So anyway, but to tell you some of the cataloging decisions we made here, of all the records there are, about 63,000 do not have any information on the original publication. So the publication data we put down is Salt Lake City, Utah, Project Gutenberg, and when the item was transcribed. And it transcribed, unlike HathiTrust, which actually scans the pages, these are actually keyed in ASCII, and they're transcribed. So they're a new edition, essentially. So when, in that case, we have a 534 note, mark tag, saying original publication data not identified. We just don't know. It's not there for all those records. In many cases, I understand some of them were transcribed from multiple editions. So we don't know if it came actually from one single book. That's another matter. Now, as of a certain point, after about 63,000 records, that has been added now. It has been put in there. So we have a 534, says originally published, such as you see in this case. And in the 008 field, fixed field, we put in, if it does have an original date, the position 6 has an R. The position 7 through 10 does have the date when it was transcribed. But if we do have the original date, we put it through 11 to 14. If it doesn't have it, well, 1114 is just unknown. That's where it is. Physical description, we don't have in the database, but it's an online resource in multiple file formats, be it Kindle or ASCII or EPUB, etc. These are standard. Thing is, what we're doing here, we're using RDA standard instead of AACR2. And that also means that mark tag 440 is deprecated with RDA, so we just moved that to 490, and with an access 830. Access points. This was tricky. The authors in the database are not delineated by personal, corporate, or meeting names. There's no indication also whether it's a forename or a surname, such as Aristotle, Aesop, etc. So we're still using one for surname in all of them. We do have the, what do you call it? 1 minute. All right, I'm going to race through this. Okay, so we managed to, even though, let me skip through that. You can look through some of this later. One important thing is concerning subjects. We don't have an indication whether the subjects are LCSH or a personal name or a geographic name. There's no subdivision delimiters via chronological form, general, etc. There's just one continuous stream. So if we use mark tag 653, which is an uncontrolled index term. So a lot of decisions were made there. Also, thinking about Brex Davis's presentation yesterday, is using ISO 639-1. We have to change that. Change it to -3 when we have a chance. All right, thank you much.
Thank you. And our last lightning talk is Mike Palmeno with redesigning a library website with Astro.
Okay, I did not upload my slides anywhere, so give me a second. Okay, go me. There we go. Oh, okay. Taking up my time with spelling errors. Okay, here we go. So I'm going to talk to you about a project we have going on at Skidmore College. On the surface, it doesn't seem like much, so let me give you some context. This was, let me start the slideshow, that may help. So this was our website when I arrived at Skidmore in 2017. Don't ask why it looks like that, because I wasn't the one who designed it. And as you can see, the navigation was all at the bottom. There was this rotator in the middle, and it wasn't terribly user-friendly. So in 2019, I went to my boss and said, can we redesign this? And she said, sure. Now, the whole process, I mean, there was this whole COVID thing which happened. And it was a whole big thing. I don't have time to talk about it, but basically the short version is we looked at 4 library websites from Notre Dame, Portland State, Williams College, and I think Union College, and just decided to take the best features, and this is what resulted. This is the bottom. And this is all well and good. We did get a lot of feedback about how much better it was, but there's a couple things that always bothered me about it. It uses WordPress. I like WordPress for what it is, but it adds complexity, it adds security risks. It's also arguably unnecessary because there's only one person who updates the website. I even asked some of my colleagues, because they'll send me things to put on the website if they wanted WordPress accounts, and they were like, we're good. So I'm creating this whole system and maintaining and updating it, and eventually I'm realizing, can we do it better? The answer is probably. I did a little bit of working and poking around and deciding decided, our website is mostly static content. So what about something like a static page generator or a web framework like Astro.js? I had been somewhat familiar with the one GitHub runs on. I don't remember what it's called, Jekyll. But no one at Skidmore uses Ruby, and I don't want to be the one person who's using the one system no one supports, and so. This is something that's ongoing. I had some proxy server stuff to work on and other things, but it's coming. I'm focusing on. I don't have any slideshots, any screenshots to show you. They're all on my work laptop, which is safely in my office, locked behind my locked door. But I'm really liking what I'm seeing so far, even though I'm having to hand code a lot of stuff. It's actually less complex. The theme, because the other issue is that the theme we are working with is not that great with WordPress. I mean, it created a fine product, but I feel like I'm fighting against it half the times. For example, I once opened the Google developer tools, and I'll be inspecting an element, and I'll see the important flag littered all about the code. But more than that, it's like I was seeing div tags within div tags within div tags. I once saw 14 div tags before you got to the stuff I put into through the WordPress interface. So far, I have not had to put nearly that many div tags. So it's an interesting case where even though it's a little technically more complicated, it's actually simpler. Like simplicity adds complexity in a way. The general design probably won't change much, but I'm using this as an excuse to make some needed changes. For example, we're probably going to make the background image smaller. It's a little hard to tell from the screenshots, but if you actually go to lib.skidmore.edu, you'll see like this much image. And oh, there's the rest of the web page. Golly gee, I wonder why InspectLit was telling us no one is accessing anything below the image. And also getting rid of the image rotator. We were actually just talking about this on Friday. It's something that like, it's been there since at least 2013, and I've never seen any evidence that people click on it. But nevertheless, some of that content is important, and so we were looking at Yale University Library website, and they have everything, the events laid out, and so we're going to using this as an opportunity to make some smaller updates, and maybe you can hear about that next year.
All right. Thanks to all our lightning talks. We are now back into full talks, starting with 15 minutes with Eric Hellman on making an accessible Winnie the Pooh.
Hi, everybody. My name is Eric Hellman. If you can't see me, I'm a bit older than I feel. Although since I ran 3 miles this morning, my legs respectfully disagree. I am wearing a garish Princeton Tiger theme shirt. And, well, anyway, I run the Free eBook Foundation. We do projects that promote free ebooks and their distribution. One of the projects Ray just told you about. But let's see, how do I advance this? Oh, we have to start it, don't we? Okay. And that's not mine, is it? Is it? Yes, it is. It is. Where should I be to start it? Oh, right here. Where is it? There we go. All right. So the first part of my talk has no visual content. You're welcome to close your eyes. We can turn down the lights a bit if you want. I'll wake you up when it's over, okay? All right. So, okay, I've said that already, right? So I'm going to read from Winnie the Pooh, which I expect most of you have read. I hope deaf people can read the speaker notes. Winnie the Pooh was published in 1926, so it has been in the public domain since 2022. A version appeared on Project Gutenberg on January 3rd of that year. Clearly, it was viewed as deserving prompt attention. Over the past 2 years, I have helped Project Gutenberg convert all of their books to HTML5 and EPUB 3 formats that are compatible with modern accessibility features. But the wonderful drawings in the book are inaccessible. There have been no descriptions. I wanted to change that. Now, to improve accessibility for the sighted members of the audience, I'm going to, instead of the features that a screen reader would have to denote structure in the document, I'm going to just sort of skip over them a little bit and minimize them. So I'll start a few paragraphs into the book. One day, when Winnie the Pooh was out walking, he came to an open space in the middle of the forest. And in the middle of this place was a large oak tree. And from the top of the tree, there came a loud buzzing noise. Image. The image appears to be a simple black and white illustration. It depicts a small cartoon-like figure, possibly a rabbit or other animal, standing on the ground. There are several small star-like shapes scattered around the figure, creating a sense of movement or energy. The overall style is minimalist and abstract. Does anybody know what image I'm talking about? So that description was written by Anthropic's haiku model. Maybe the so it's an older model. So let's try the newer, more powerful, smarter, larger model. Let's see what it has to say. Image. The image shows a simple line drawing of Winnie the Pooh looking up at several bees or other insects flying in the air above him. Better, isn't it? It isn't. I mean, it sure is a lot better than the first one, right? So that was the Opus model from Anthropic. So let's read on. Winnie the Pooh sat down at the foot of the tree, put his head between his paws, and began to think. First of all, he said to himself, that buzzing noise means something. You don't get a buzzing noise like that, just buzzing and buzzing, without its meaning something. If there's a buzzing noise, somebody's making a buzzing noise. And the only reason for making a buzzing noise that I know of is because you're a bee. Damn it, Opus, you spoiled the narrative. He wasn't supposed to know that they're bees. They're just sort of way up there, hard to see. Anyway, so you can see that the alt text produced by AI is kind of clueless about how the story goes. It doesn't pay attention. So I decided that I would write alt text for all of the images in Winnie the Pooh myself to get a first-hand feel for how this works. They're now used as the alt text for the version of the book currently being distributed by Project Gutenberg. Here's the alt text description I wrote for this image. In this drawing, Winnie the Pooh is peering up. There are tiny things swarming around up there. Winnie the Pooh sat down at the foot of the tree and put his head between his paws and began to think. First of all, he said to himself, that buzzing noise means something. Okay, So that's the end of the reading from Winnie the Pooh, along with various alt text possibilities. I wanted to give you an understanding for the difficulty of writing alt text and how AI can possibly help us with that. So a few things, a few points. Number one, it's really amazing how well AIs do at describing images. It's really amazing. Two, good alt text is much more than image description. It needs to be aware of context, and indeed we've found that providing more context can result in better AI-generated alt text. It can also lead an AI astray, resulting in really worse alt text. It needs to fit in with the surrounding text and to use the same words in the same language as the text. So the third point, and I think the most important point, is that authoring alt text can be really fun. It's like doing, when I was doing Pooh, it was like doing 100 fun little puzzles, trying to figure out exactly the words that would have the same effect on the reader as the image did. And those images are, I mean, they're iconic. You all have a picture in your mind of what that image looks like, right? Because you read the book and you remember it. So I thought it was worth extra effort for this particular book. All right, you can wake up, everybody. Okay, visual content. All right. So in Project Gutenberg, it turns out there are almost 500,000 images without alt text. So that's a big project. Now, that's not something I'm going to put a dent in if I do it myself. It's not even, I mean, even if we have 300 volunteers or something like that to help us, it's you know, going to take a while, and it's going to take a fair amount of effort to address the accessibility of a large fraction of the books in the collection. Another thing about the alt text in Project Gutenberg is a lot of it's really bad. You know, things like image not available. I mean, imagine yourself as a blind user going through the book, and all of a sudden it says image not available, or pick, or figure 3. Now, that's really driven by validation. In order to validate, to get the HTML validators to pass the HTML without an error, there has to be something in the alt text, or else it spits out a warning. Now, a lot of times you really want nothing in the alt text because maybe the description is in the regular text, or if it's just a decorative image or something like that. But to a blind user, and I've talked to blind users about this, even bad AI descriptions are better than nothing. Because without nothing, you don't even know what you're missing. So here's an example of a figure which if a blind user encounters it in a paper that they're reading or a book, they're going to totally miss out. And in this case, the publisher alt text, this was from a real publisher. This is not from Project Gutenberg. The publisher alt text was figure C010.F002. Thanks, publisher. Now, some publishers do a good job. This is what AI sent back. This is not even the most powerful model. The line graph shows the survivorship percentages over time from 0 to 96 months for different groups, such and such and such and such. The survivorship rates generally decrease with age for all groups, and some groups declining more rapidly than others. The K-tau group has the steepest drop-off, reaching near 0% survival by 48 months. Now, I couldn't write that alt text myself. That's really good. It's amazing. So, yeah, sometimes the AI does really great. Claude says, "Hold my beer." All right. This is an image of a horizontal line, which the publisher alt text says image10.png. Thanks, publisher. Claude says, the image shows a close-up view of a gray wolf standing in a grassy field. The wolf has thick, great fur, pointy ears, and is looking directly at the camera with its golden eyes. A shallow depth of field keeps the background blurred while the wolf's face is in sharp focus. That's the more powerful model. Oh, so this is not in color, okay. And the emojis aren't all present in the Unicode font on this computer. But anyway, so what I think we need is collaboration between AI, that's a robot head if you can't tell, and lots of people. Those are lots of people. All right. So AI plus crowdsourcing is what I think, the way I think we need to go. And what did that say? Anyway, this font is terrible. Yeah, so I call this MI, or multiple intelligence. All right, so we've started working on an app for editing Project Gutenberg, well, at present just Project Gutenberg, for editing Project Gutenberg alt text. On the left you see the image that I was talking about earlier. That's Pooh looking up at a bunch of what we now know are bees. And on the right we can navigate through the different pictures in the book and review AI suggestions if you want, and pick the right one out. And this is a work in process. I'm out of time. Okay, let's go on. So we really want good alt text. And the reason the alt text is bad at AI is sometimes because the training data is created for SEO and from social media. There are a lot of cases where we really need AI to be good, because the AI needs to be really the best alt text is different for different disabilities. So this is my last slide. That's an example. So that character is the Chinese character Dao, or the way, as in Taoism. And this is kind of poetic, what AI thinks, don't you think? Anyway, I'd like to shout out to Rowan McCarrigan, who worked on the React front end. This is his first Code4Lib. Where are you, Rowan? Hi. Great. And he's looking for a developer job in library world.
All right, and now we have continuing the conversation, building open source semantic discovery tools with David Schober and Brendan Quinn. You have a PowerPoint?
PowerPoint, yeah. In the conversation. Might still be in the folder. Oh, it's not here. Oh, here it is. Oh, fancy stuff. Well, thanks. Awesome. Hey, everybody, can you hear me okay? Is the lapel working? Great. Hey, I'm David Schober. I'm a long-time listener, first-time presenter, which is fun. I'm the lead product manager at Northwestern. I'm here with Brendan Quinn. He's a colleague of mine, a member of my team, and he's our lead AI engineer. Today, we're going to talk about our work leveraging generative AI tools in a search and discovery context. Specifically, we're going to talk about how these tools can be leveraged to enhance the use of digital collections. In August, we were awarded a 2-year IMLS National Leadership Grant. And the grant had 3 different parts. One was to enhance our in-production semantic search system, which we'll show you a little bit about today. Second, we were tasked with creating a chat-based discovery platform, an open source chat-based discovery platform that's easy to install so that folks can experiment with it if you want to get your hands dirty in this tool. And third, a tool to help augment metadata. That last one we haven't quite started on, so you'll hear about that probably next year. Just a quick call out to the software development team and the subject matter experts on this IMLS grant. I'm not going to read everybody's name, but they're there, they're awesome. We have a great team. So again, what we're going to talk about today, we're going to talk about how we, we're going to talk about how we went from prototype to production with our semantic search tool. We're going to talk about testing and validating it in a couple of different ways, both automatic testing tools as well as human testing tools. We're going to talk about new agent-based workflows that we've been working on the last couple of months that we're just about ready to release, and that's what we're going to show you the most of. And we're going to talk about extracting the work so that it's installable by you all. So first, we're going to talk a little bit about when we got started and how we got started. About 1.5 years ago, close to 2 years ago now, ChatGPT 3.5 dropped, and it was, as many of us know, it was sort of shocking, right? We looked at it, we weren't quite sure what it meant, and it was this brand new tool, and we very quickly asked ourselves, what can we do with this? And it became, to us, it became very clear that this could really change how users interacted with digital collections in our search, in a search context. So Brendan in particular took it upon himself to build a chat prototype, and then we displayed it to the team, and then quickly went out to the rest of the library. And from that simple proof of concept, it became very clear that this was going to change how we were working. So first, with this prototype, we created a semantics embeddings of all of our metadata, so numerical representations of all of the metadata from all of our works in digital collections. And we spent a significant amount of time learning about vector databases, what they meant, how they worked, and in particular, how they worked alongside traditional search. Because traditional search is really good. We've had a lot of time and experience working with it. But semantic search does something entirely different, and it's amazing. There's no reason why they can't work together. And we developed an interface that allowed people to ask some really simple questions so that we could get it in front of users. We did this really quick, within the first month and a half or so. And early testing with users showed not only that it worked, but that digital collections was kind of in that sweet spot. It had a couple 100,000 works and a few 100,000 file sets, so it was big enough that users could really ask hard questions and get real answers, but small enough that we could really rapidly iterate on it. In addition, it really challenged our assumption at the library about how users want to interact with our collections and what they wanted to ask. So we began to imagine how we could integrate this into our system generally. We went into a design phase. In the upper right there, you see some real quick wireframes. So we did this in about 9 months. We went from prototype to production. And our goal was to not create a sidecar, which I think is what a lot of folks are seeing now, but rather to dig it right into digital collections so that it was just part of the experience. Put a little button that says use generative AI, and your search is now is semantically powered, as well as generative tools wrapped around it to answer questions. Got to do this twice each time. So from the very beginning of our proof of concept through just last Friday, in fact, I think another test was happening this morning, we've used every opportunity to put it in front of users. In addition, we've developed a bunch of automated testing tools, which we'll talk about a little bit, and that are up on GitHub for everybody to play with if they want. Testing chat-based tools is very different than traditional user testing in our experience. We're testing how a user responds to natural questions as much as how a user interacts with the system. I'm sorry, we're testing with how the system responds to user questions as much as how a user interacts with the system. This is a little bit different than, in my experience, traditional user experience testing, where we have a known quantity and you're asking a user to interact with it and you're tweaking the system behind. Really, the question is, how is an LLM going to respond to this brand new question from a user, and how a user sort of interprets that response? There's a lot more emotion going on, to be frank. All right, so first, a little bit about user tests. Again, on the traditional side, we used basic user tests. We put things in front of users, and we just started asking users to ask questions. And we learned a lot about the types of questions they asked. We did a lot of really fast and rapid feedback loops with people in elevators, wherever we could get someone to open up a laptop. And we created anonymous feedback forms, sort of picking up from the industry. Thumbs up, thumbs down, hated it, loved it. This is what was awful, this is what was great. In addition, what we ended up learning was that a whole lot of users, especially our newer researchers, were very comfortable interrogating the systems. And this goes right back to the beginning. So right when we put it in front of folks were asking questions that made sense to a chat bot. They weren't necessarily just asking keyword-based questions. They were asking questions that needed real answers. Where did that? Oh, that. And finally, on our automated testing tools, we developed a couple of frameworks. The first was a really lightweight command line tool that allowed us to ask real user questions over and over and over again. And the reason that this was really important for us was because not only did we want to iterate quickly on our prompts because we were learning a lot, but these models have been changing rapidly. We've been through 4 since go live, right? Since we started working on this. That's a lot of churn. You can't like lock into a model and be done. And every time you change a model, everything changes underneath it. We also wanted tools to be automated and fairly hands-off so we could do red team testing. I know a lot of the folks in this room, I know my team, I hire really nice, good people. So to ask those people to come up with really terrible questions feels unfair and mean, right? So we used an industry data set from Anthropic so that we could beat up the system in ways that people would try to tweak it without us having to come up with really terrible questions. Because we're pretty sure folks are going to try to break it. The final bit here, before a quick little demo, is that we started to give agents access to more tools. Those of you not familiar with the term, agents are initial in-development system, or in production system, which is in production right now, is a single turn. A user asks a question, goes up, performs a semantic search, comes back with an answer. An agent-based system allows this system to have access to predefined tools. And in our case, we started with 3 tools. One is discover field, so it interrogates what it has access to, so it knows what it can ask questions about. Second, an aggregation query, which are fairly complex queries. We decided to start with some simple ones and some more complex ones, and then a similarity search. So the agent itself makes a decision based on the question, based on the context of the question, which direction to go. This really changes how users can interact and the types of questions they can ask. In addition, they can ask follow-up questions. All right, let's see if this works. Here we go. Quick little demo. So first, a user here is going to ask a really general question. In this case, they're going to ask what they might find in the system. Can you all see that? It's a little fuzzy. The agent thinks really hard. It says, I'm going to go ahead and discover some fields. I'm going to aggregate on the field of collection type and also grab some information about those collections, give some counts so you can get a feel for what you're looking at, and then does its best to answer the question based on the context of those results, right? So it's made a decision. It's asked a fairly complicated search in this case. It's aggregating by collection. This next one here, I'm asking a more specific question about the great blues singer Big Mama Thornton, which we have a bunch of black and white photos of her in our collection. We ask how many. It's taken a different approach. So it just did a similarity search and then does a count based on the metadata. In this case, returns results to the end user. And here the user is looking to refine a little bit. So we wanted to make sure that they had the ability to use traditional search filtering and faceting techniques. And this is on the neural search itself. This is on the semantic search. So a lot of folks lose that ability. We did a lot of work to allow traditional searching and faceting within the context of semantic search. Here you see this is a metadata issue. They asked for photos. We found negatives. There's a few more negatives than that. This last bit, I've asked a question here in Chinese. I've asked how many or whether there are any photos or paintings of elephants in the collection. And this is was surprising to us, but amazing. Simply by adding this tool, we now have a multilingual search and discovery platform. Our metadata in this case is in English. I've asked a question in Chinese. Because of the way semantic search works, it's gone off and gotten the paintings of elephants, brought back those results, and it's answering in Chinese with no extra work. With that, I'm going to pass it off to Brendan.
Make sure I turn on my microphone. Testing. Oh, that sounded real. Well, real deal. All right, so let's see. All right, so I'm going to talk a little bit about what we've done to take what we've learned building that digital collections chat feature for our users at Northwestern. And we're building it out into an installable product. So this is work that is, the lion's share of this work has been done by the team that was on our second slide. So shout out to the team back at home. Thanks for all your great stuff. So I'm just more reporting about what they're doing on this particular part of our software stack. So what you see on your screen here is this is an image from a design session at the beginning where we were thinking ahead to the end, like what would it look like for our end users to see a landing page for this product. And so we came up with this sort of copy and this idea of just an install button. So the idea for our platform is that you would have the only thing you need to start experimenting with digital collections, like with your digital collections, is an AWS account. That was our idea. So you just hit the button. So we support other software that has a similar feature to this, like serverless IIIF. So we're building off of our knowledge there and sort of applying it in a new space. So the idea is to have us handle the technical implementation of that stack, and then have the end users just worry about installing it and interacting with generative AI over their data. All right. Make sure I didn't miss anything. OK, so yeah, we need the stack itself. Like when you hit the install button, what will happen, and I'll show it on the next slide in video form, is that a whole bunch of AWS services are created for you on your behalf. So that means S3 storage buckets, Aurora Postgres, SQL serverless database, Fargate tasks, Bedrock, AWS Bedrock connections to the LLMs and language models and the embedding models, API gateway endpoints, and an Amplify app for a front end. So it's basically everything for a whole application stack. So that's the idea. And then on the next slide, we have a video. Let's see if I can see it. So I'm going to pause it really quick. So this is I'm zoomed in to the front end user facing application, and then in a second I'm going to zoom out and show you the full stack underneath it. I just wanted to pause for a moment. All right, so there's the actual stack. It's a lot of services all working together on your behalf to make an application. Okay, so we can see here we've got adding a Cognito user to the Cognito user pool. So there's authentication built into the system. So here I'll be creating a user and a password. So there's Code4Lib user. And so when the user signs in for the first time, there'll be a password reset, and then we'll have access to the system. So you can see there's a couple of users there. There's my Code4Lib user. Here you can see my what happened when I kicked off the stack, was there's a default IIIF collection that we're using for our data. But the idea is when you hit that install button, you could have your own IIIF collection, or we're also talking about MARC records and finding aids as future formats. But our first format is IIIF. So the default is one of our internal IIIF collections. But the idea is you could have, with that install button, you go to a page, you fill in a form with your publicly accessible IIIF URL, and it pulls the data for you. So in this case, you can see the step functions that are pulling this manifest. You can see the collection URL on the side. And so these step functions download each manifest individually and create embeddings out of them so that they can power the retrieval interface that I'm going to show in a second. OK, so there's the URL to the Amplify app that gets deployed in the stack. And you can see I'm going to sign in as the Code4Lib user and then reset my password once that works. And then maybe I'll pause it on the next screen here before it just finishes. New password, super secret. All right, so this is the interface. It's really, really simple for now. This is like a pre-alpha unreleased version of the software. So this is like, we're really showing you the work in progress. And so this is just a simple form, but underneath it is those embeddings and a language model that are pre-configured so that when you ask a question, it does a RAG retrieval and answer just like what David showed in the previous slides, but this is just a much simpler version for now. So I'm asking just a question, are there postcards in the collection? Just as an example, and then I hit the button, and then so it's going to do the retrieval using the Bedrock knowledge base and the embeddings and show the result here. So it says, yes, there are postcards in the collection. There is at least one color postcard that depicts the Obama's family visit to Ghana. And then you can see, so there's the answer, but also the content, the retrieved content that was retrieved from the IIIF collection as part of the answer to the question. Cool. And I think that should be the end of the video. All right, so here's a slide about why are we doing this at all. We've been doing a lot of user testing with students, faculty, and researchers on campus over the past few weeks. And David and I thought we pulled out this quote from one of our testing users. It was a student who said, it's almost like being able to look into a little museum and you kind of start to explore from there and just follow your train of thought and what you're interested in and have that information handed to you so easily. And so I think what this user is describing is kind of like a different experience with library resources that wasn't possible before on the web. This is kind of a new thing where it's like they're collaborating with the AI to refine their questions and get more relevant material. And it's sort of this like refinement conversation approach that's in their own language, like in Chinese or English, as we've shown. So the user is able to like bring themselves in a new way to these experiences. And so what does the library of the future look like? So we have lots of questions. We have questions like operational questions about like what persistence and storage of these embeddings, like we're storing numerical representations of semantic information at scale, and we have metadata describing those, and we're just sort of basing a lot of our work internally on the machine learning and AI space and not the library space. Like we're using metadata best practices from like their APIs instead of library APIs. So like there's conversations that I think I would be interested in having about those kind of operational things, like data sharing and interoperability. If we're all generating these embeddings individually, could we share them and maybe save some effort? And then if you share them, what metadata do you need to tell somebody how you generated those embeddings? So things like that. And then, enhanced accessibility. We've seen lots of examples of the past 2 days about, transcription, images, and audio. Like what does that look like for, changing legal requirements and things like that. And then also just changing user expectations. One of the things that comes about in these user studies is just people just naturally just ask their questions in their own voice, and they don't have to use Boolean logic, and they don't have to like translate their thoughts into library speak in order to get their results. They just bring themselves and they ask their questions, and they're doing that everywhere on the web now, not just in library spaces, but everywhere. The expectation, I think, is changing about what is a form, like what does a form do for you on the internet. Okay, so here's a bunch of code links to code examples. We have the first two are the production sites that are there, but we have a new repository that we call NU Lib Labs, which is really fun for me to say. I say it as much as I can. And so there's a bunch of repos. Like there's one here I wanted to call out, Loam IIIF. We have this like earthy kind of eco terminology that we like to use. So we have Loam IIIF, and that's actually used internally in that AWS stack that I showed to pull down the manifest. So we made that a separate tool. So it actually comes with the CLI and Python tooling. So if you want to like pull down IIIF collections from the web, like you can use that. But we're also using it in our stack as well. So we're trying to break things out where it makes sense. So thank you. I think that's it for our time.
All right. So last speakers of the morning, we have Jeremy Prevost and Matt Bernhardt with a search intent detection API, or what if we tried to understand keyword searches instead of yeah, I'll let them say it. This is a very long title.
Okay, we've got audio. Hi, we're here to talk to you today about a search intent detection API. There's a lot longer title that I'm not going to read for some reason Matt didn't. So we're going to talk about an API that we are building at MIT Libraries. I'm Jeremy Prevost, and this is Matt Bernhardt, and these are our pets, if I push the button on both computers. So we have a colleague, Isra Jazairi, is also part of our team, but they did not make the trek to Code4Lib this year. And we are a software engineering team at MIT Libraries. There are 3 animated graphics with a little bit of motion in case that affects anybody. It's not, I don't think it's too bad. We'll see. But before we begin, we must ask ourselves, what is a taco? So a taco is a traditional Mexican dish consisting of a small tortilla topped with a filling. What is tacos? Tacos is a real-time anonymous keyword search term collection and categorization system. It's a GraphQL API, and it stands for a tool for analyzing and categorization of search terms. And why do tacos exist? They're delicious. And why does tacos exist? To help us explore if we can detect user intent, improve relevance of search results based on user intent, and skip traditional search engines entirely for certain types of searches. It's not quite time for lunch. First, we're going to review some traditional and bento discovery flows. We're going to introduce our long-term goal with our tacos work, which is different search results based on different intents. And we're going to describe what we can currently do, which is not that yet, but we can augment some existing results based on extracted information. And we're going to explain why we have not used AI at this point. And then we're going to go eat lunch. So sorry, I'm trying to get my slides synchronized again. In a traditional discovery environment, in its most basic form, we have this flow in which a library discovery application presents a user with an interface. That interface will end up querying a search engine of metadata records for whatever search the user supplied. The details of the interface application and search engine will vary, but the pattern is common. Some examples might be Blacklight, Primo, or custom interfaces, and for the search engines, oftentimes we're using Solr, OpenSearch, or Primo, or Summon, or something like that. And this is an example of our Primo VE interface. I'm sure you've seen lots of things like it. It happens to search our Alma records in Primo Central Index and interleaves the results into one set that users can apply filters to. In a bento interfaces, which were and are still to some extent a popular method to give users a tease of information from various sources in the hopes that it will help them find the most appropriate search system to continue their information quest. In this case, we just create a box or tabs for each search engine in a single interface. Bento interfaces don't try to understand what users want. They just send the query largely untouched to a few search engines and hope that one of them has in the top returned results something the user will find helpful. And this is a screenshot of a portion of our bento interface.
So what if we did more than just throwing terms at search engines? Doing more than throwing terms at search engines is where user intent and the taco system comes into play. User intent when searching can be broken down into several broadly understood categories. Names for these categories differ from field to field. and some aren't relevant for a library context, but we focused on 3 categories to guide our work so far. The first of these is transactional. In this case, in the library world, that's known as known item or specific item. The user has a specific item in mind and wants to get to that thing. And the ideal outcome is to either provide a link to the item or send text back saying, this is how you get this item. The second category is informational, kind of open-ended topical search. The user's looking for broad information, not one thing. And the ideal response is either to link to something like a subject guide or send them browsable results, not just one item. The last category that we're calling navigational or directional, the user has a need that we can help fulfill with a service that the organization provides. The ideal response is to either link to that library service or refer to the user to a human part of your organization for further fulfillment. So how might these categories get incorporated into a discovery flow? In this series of diagrams, you can see how the Taco search intent detector can be used to augment a user's query and allow a search intent to behave differently based on what we can detect about that user's intent. The process starts with a search interface sending the query to the intent detector for analysis. The intent detector processes the query and reports back what it finds, if anything, to the interface. The interface then hands the original query and any additional context to the search engine. The search engine is configurable with a variety of different algorithms available for use. One is a generic algorithm, which is what gets used if the intent detector reports nothing. That's traditional keyword searching. The other algorithms are tailored to the kind of responses each category might need. In the example here, the query has been categorized as a transactional search, so known item. So the search engine is using an algorithm appropriate for that kind of search intent. The flow concludes when the search engine returns an appropriate set of records to the interface, which are then shown to the user. We have a few caveats about this flow diagram. One, we aren't exactly sure yet how those algorithms are going to be customized for each category. We do have some general ideas, but those will be refined during implementation work that will be starting very soon. The second is that some of those categories of search intent might cause the interface to choose an entirely different search engine, rather than having just one engine with multiple algorithms. There might be a kind of hybrid situation where you have multiple things. For example, navigational searches might be best served by a simple query into a relational database of services, rather than trying to surface specific records via weighting or something out of the 10 million or more records in your Elasticsearch index. The system we're describing in this presentation doesn't implement a new UI pattern. We're focused instead on making sure that the right results show up in a way that is already familiar to users. Users will almost always see a list of results, even if the way that those results are generated might be different based on the user's type of search. So are we there yet? Not quite, but we are able to use some detectors to create some interventions now.
We built so far works like this. The search interface interacts directly with a search engine, just like it does in our traditional or bento examples. The difference is that the interface also queries our intent detector at the same time. The search engine does its usual thing, returning a set of records based on the query. If the intent detector finds nothing, nothing extra happens. But if the detector gets certain types of matches, then it looks up extra information using third-party services like Crossref or libkey. The intent detector then sends back an intervention to the search interface, which adds it to the UI in a prominent position. This intervention can either be a JSON object that gets rendered by the interface or HTML fragment that gets injected directly into an existing interface, which can be really helpful when we have less control over the interface's rendering templates. Our primary search interfaces are actually pretty good at some of the types of things we can currently detect, such as this search for a DOI. We may not need to inject a DOI intervention into these types of interfaces. Where interventions for a DOI might make sense is on interfaces people search regularly, but are not connected to our mega index. This example shows our DSpace interface with no results for a DOI on the left and on an early version of our DOI intervention on the right. Why would someone search an institutional repository for content that's not from your institution? You may understand what is in scope for your institutional repository, but that doesn't mean anyone else does. Similarly, we could add this intervention to archive space or our website search or anywhere else with a search box that we felt it would be helpful.
So now is the big question. Why not AI? Everybody else seems to be doing it. What are we doing? When we started this project, We thought it was important to understand this kind of a problem space using traditional coding implementations rather than just turn to the big magic box, because we needed a baseline to compare it to. Frankly, we also needed a tag training set to consider training anything, and we didn't have that yet either. Now, at this point, a couple months into the project, we still believe that efficient and highly accurate non-AI algorithms probably make the best sense as a starting point, and then use AI as a comparison afterwards. Machine learning, not necessarily AI or into Gen AI, may be useful to supplement that approach. We are actively evaluating some options for machine learning algorithms at a few places in the application now.
Who can use tacos? Well, it was developed for internal purposes. It's open source. You could run yourself. We don't necessarily recommend it. But if you have ideas, we'd love to talk to you. And we are out of time, so thank you. And awesome.
All right. So that wraps up the morning. Just a couple quick things, and then you guys can go enjoy plenty of fine noms from Princeton here. So if you're an in-person speaker during the lunch for the afternoon, during the lunch break, make sure you come and ensure that your presentation's loaded here. If you're a poster speaker, make sure to get your poster up before the poster sessions this afternoon. The building will remain open, but unsecure, so leave items at your own risk. Again, lunch will be in Prospect House like it was yesterday. Should remember the way. If not, follow Shapiro Walk, cross Washington Road, turn left at the quad, exit the quad, architecture, music buildings, it'll be on your left, or just follow the flocks of awesome lib tech people that are fleeing to get food. So thanks for joining us this morning.